So within the energy transition to clean fuels, there are new emerging measurement challenges. Many of these are focused on the use of hydrogen as an energy vector, or they are related to the supporting CCS operations. So on the CCS side, one of the issues is that the gas-liquid phase boundary for carbon dioxide occurs at relatively low pressures and at temperatures close to ambient. So this means that we have a need to accurately measure the flow rates of carbon dioxide, both in the gas and liquid states, which necessitates two very different calibration facilities. It gets more complicated when you realise that for CCS operations we aren't dealing with pure carbon dioxide, and instead we have CCS mixtures. And with mixtures there can be two phase regions on the phase diagram, and the boundaries of those regions will change depending on the mixture composition. So we now have a need to accurately determine the mixture composition and the temperature and pressure at various points in the CCS value chain, so that we can tell when it's a gas, when it's a liquid, and when it's a two-phase flow. With hydrogen, on the other hand, we aren't concerned about phase change, but there are different concerns. Working with hydrogen is difficult because of its hazardous properties, including its wide flammability range, but also the low density of hydrogen introduces some measurement challenges as well. So for a fuel cell vehicle refueling, because of the very low density of hydrogen, we have to compress it to very high pressures to get a reasonable energy density. So it's typically compressed to up to 700 bar. And what this means is that for a 3 to 5 minute refueling period, the hydrogen heats up quite a lot because of the compression to the high pressure. So the hydrogen is normally supplied at very low temperatures, around -40 degrees, and it can heat up to around 60 degrees during this refueling period. So we're dealing with very wide pressure and temperature ranges, which are difficult conditions for flow meters to operate under. And also, if we want to calibrate the flow meter under representative conditions, then we need a very expensive calibration facility to enable those calibrations. So for the last 3 years, we've been developing new measurement capabilities for hydrogen and for carbon dioxide. In March of this year, we opened our domestic gas meter facility for hydrogen, which can operate with hydrogen, nitrogen, methane, or mixtures of any of those two gases. At the moment, we're using this facility for a test program for a representative sample of domestic gas meters operating with up to 20% hydrogen. And that project is intended to support the ongoing High Deploy project in the UK. We are the designated institute with responsibility for the national flow measurement standards in the UK. So with all these new emerging measurement challenges, it's more important than ever for us to understand the needs of industry and to be able to provide the necessary measurement traceability. So I just want to emphasise that if you have an application where you have to accurately measure hydrogen, carbon dioxide, or any other fluid under flowing conditions, then please get in touch with us.